Great, thanks. Hi, everyone. My name is Mike Steers. I'm a consultant in the secure infrastructure domain in Toronto. My main focus is Azure and Azure DevOps. There's been a bunch of excellent presentations related to Azure DevOps in this study group, and one of the frequent requests we get is to start from the basics. We touched on topics like CI, continuous integration and continuous delivery, Terraform, ARM template deployments through pipelines and repos, but there was some demand to show the progression of how to get to using all of those fantastic services from the beginning of the development lifecycle. So Claudia, Len Volk, and I came up with the idea of having a mini boot camp for Azure DevOps. Len will probably be helping out in presenting some of the topics in the future too. I'm also going to be taking the AZ400 exam, which is the Azure DevOps exam certification, and I find one of the best ways to prepare is to teach someone else, because it means I have to prepare for all your challenging questions, which are usually much more difficult than the exam itself. So feel free to point out any mistakes or ask any questions along the way. We'll be getting you familiar with the main capabilities of Azure DevOps and taking you on like a fun little trip from understanding source control, creating a basic .NET Core web app, deploying it to an Azure app service through CI/CD, which is continuous integration and continuous delivery. I'll be saying CI/CD from now on because that's a mouthful, and creating test plans, improving the project through iteration. So our schedule is going to look a little bit like this. Throughout the next 6 to 8 sessions, we'll be using Azure Repos, Azure Boards, Azure Artifacts, and Azure Pipelines for the CI and the CD, and we'll be deploying to multi-stage. We'll have multi-stage deployments for our web app to POC, Dev, UAT, and prod environments, and the test plans to validate. So the schedule looks a little bit like we're going to have one session every 2 weeks, and the week in between, if this works out, we'll have a Q&A session for some optional homework. Because another one of the requests we had out of previous sessions is, can we just have a general Q&A session about Azure DevOps? So by taking this approach and separating them into little tiny modules, we'll have a Q&A about each section as we progress through it. This week we're going to be talking about development processes, which is mainly source control, using Git and VS Code and Azure Repos. Next week we'll talk about building our releases, which is continuous integration, or 2 weeks, sorry, and in between homework, and then so on. So our objectives for this, and hopefully it'll be a little bit fun because it'll be taking you on the whole process from start to finish. We're going to create, build, and deploy and improve a .NET Core app service. This is a little bit selfish as well because I'm always looking for an excuse to force myself to learn a little bit of C#. So we're going to use a .NET Core C# app. We're going to manage our code in Azure Repos using Git and VS Code. We're going to manage those features that we want to add to our C# application using Azure Boards by documenting features and bugs and tying them back to our code. We're going to enable continuous integration, which is the building and compiling of our project. That will be then later used for continuous deployment, which we'll also be using Azure Pipelines for, and that'll actually deploy our code to Azure App Service. Once it's there, we're going to validate our code by using DevOps test plans, which I think was another big request for a demo on. Then at the end, we'll review our strategy and talk a little bit about DevOps Server for the on-prem scenarios. Also, I say 6 to 8 sessions because we're not quite sure if some of them are going to need 2 sessions. Like the CI/CD stuff can get pretty deep, so we may end up having, like, I don't know, a 3rd session to catch up where we weren't able to cover a lot of things. So just getting started, what is DevOps? I thought this was kind of neat. In PowerPoint, when I selected File New, it asked me what kind of outline I wanted, and just for the sake of it, I typed in DevOps and it made this slide for me. So I didn't want to erase this wonderful definition because someone probably put a lot of effort into figuring out how to generate a slide like that just from me typing that. So that was pretty cool. But in general, DevOps is a process. It's not a tool. It's an integration of people that have like a stake in the process revolving all around developing a product. The goal is to increase the performance of deployments of software. It makes more cohesive teams that are aligned with the same goals. And it's that merging, of course, of the developers and the operations people. It allows them to adapt to change through agile methodologies instead of waterfall, which in turn, of course, allows the scaling of their solutions based on business demand because they can rapidly iterate through the changes. It also makes us more critical of our code through code reviews as a form of approval. When we're committing things to our source control, there's an approval process where usually someone else will have to review your code to say that it's okay. And we're going to go over an example of how that works. And then the ultimate goal usually of this using source control is taking advantage of automation. So I said DevOps is not a tool. However, Azure DevOps is a tool. And it's the tool or product that enables those DevOps processes and goals that we were just talking about. Source control, you've probably heard this before, code doesn't exist until it's committed into source control. Source control is the fundamental enabler of continuous delivery. CD being you make a change in your code, it goes through an automated process, which we're going to cover over these sessions, to the point where it's ready, approved, and deployed into your environment with minimal human interaction. Because the process will give everyone confidence that as it goes through all these checks, it will be safe to deploy to production. Not everybody gets there. Some people still have manual human intervention when it comes to production, but ideally, that's usually the big goal, is continuous delivery to production. We can't achieve those DevOps processes with code being stored in various places with no automatic method of collaboration. So some of the advantages of using source control, and we'll get into a demo in just a few minutes. So some of those advantages, which of course coincidentally are part of Azure DevOps, are creating workflows. So the workflows are they're gonna standardize our development processes by using predictable tools. Version control provides process enforcement so everyone stays on the same page, and it basically solves the problem of people asking what changed when something doesn't quite go the way you expected it to. And it solves that question because it puts all the changes front and center in front of everybody working on the project. And equally as important, you also get confidence. Confidence is super key here because every change you make has a small comment explaining what changed. These descriptions are going to help you follow changes in like your code by version or commit tag instead of individual file changes. So, you know, like that example on the very last line there where people are saying app0_final_final in caps number9.ps1. You don't have to have those crazy file names anymore because there's going to be a history of everything that you're changing every step of the way. So the confidence gives you, it gives you the confidence, I guess, to experiment, because you can keep going down a little bit of an experimental journey trying to figure something out. But if you later on realize that, oops, I shouldn't have gone that far, you can revert right back to the spot where you know everything was working and get back on track. Two more things that it gives us is collaboration. You get to synchronize your versions and make sure that all of your changes don't conflict with other changes from your team. It prevents the conflicts by merging and making sure that when people are working on the same project, they don't step on each other. And lastly, it gives us that automation, that ultimate goal of continuous delivery. You want to be able to iterate through your code and have it deploy automatically, eliminating delays and approval wherever possible. And you can automate finding bugs even with code reviews, and we're going to go over that with those test plans in Azure DevOps. A few quick best practices for source control. They always say, you know, make small changes, commit early and commit often. Every change that you make that has like even a minor impact, but you know it's working, that's a chance to commit. Don't commit any unfinished work that could break your build, that CI component. Don't commit like secrets or keys or passwords to your code. That's what Azure Key Vault's for, and we'll go over a demo of how to use that. Update your repository often to always see what other people are working on, so that helps avoid those conflicts. You don't overwrite the same line in the same file that someone else is working on. And you want to verify your code before you're saving it and pushing it to the repository for everyone else. So that way, everyone who syncs, they have confidence that what they're getting is stable and something that they can work off of. And of course, we'll show this as well, but use commit comments. Commit comments, every time you make a change and you save it, is considered a commit. You have an option to send. It's just a little small amount of text. It's not even as big as a tweet, is where you can say what you're doing, what the change is, or what you're expecting to happen. And that's just your reference point. So when you're iterating through all those things really fast and you do go down that path where you're like, oops, that was the wrong way, you can pinpoint exactly where you need to go. And one other cool thing about using Azure DevOps, and when we get into Azure boards to track our changes and stuff, you can link your code changes to work items. So every time you're working, you're assigned a task in your project, you can link that task to the actual commit code that you entered when you were saving your changes. So if you're wondering like what committing and pushing and merging mean, we're going to go over those in a second. But you need to be aware of two types of version control. There's centralized. A popular one is TFVC, and distributed. So centralized is it's exactly how it sounds. It's one central location for all version control. We'll show a quick piece of it, but we're not going to be working with this too much. But it's important to be aware of it and why you want to choose one over the other. With centralized, there's a central copy of all the code. Typically, team members only have one version of each file on their dev machines, and it's considered the one true source model. Whereas with distributed, which most popular is Git, we'll be using that for all of these sessions. Every developer has a copy of the entire repository on their local computer. So that's why this second image here shows the same blue logo for Git on every single place and origin. So there is still a central server, but everyone who's using that repo, they download an entire copy of it and they work on that. I guess the decision about which to use usually just like comes down to flexibility. If you require centralized control and all development has to be done while connected to a source control server, then the answer is obvious. Perhaps like all dev work needs to be done on a secure workstation that requires remote access. That's usually where this stuff comes in. If you require people to be working in like all kinds of different conditions, like on a beach without cellular service, distributed is key, and that's why Git is so popular. People like from all over the world can work on OSS projects, and there's minimal management involved other than them needing to know the address to the repository when they're ready to sync their contributions back. We're going to go over these Git commands. I'm not going to talk about each one. We're going to go and do a demo of them, but if you need them, the slide will be posted so you can take a look. And we're going to be talking about branches, pushes, and pull requests. The image on the side is what is used to refer to a branch. That main gray line is called the master branch. And then the branches, well, yeah, the branches, I guess, that are coming out from master, those are called branches, of course, and you see feature/description and bug/description. That's a common naming convention for your branches. And what a branch is you consider the master is your working production candidate. You can safely assume it can be trusted from a functionality perspective. When you want to add a feature to your code or make a branch, give it a name and work on it until you're satisfied with the results, which is what these little dots are. These are your commits saying, you know, you're working on it. It's getting to the point of where you're ready to say, I'm satisfied this is working as expected. And that's when you perform a merge or a pull request or a purge. They're kind of interchangeable depending on where the action is happening. So you do a pull request, and then your code here in this feature branch gets merged back into master, and then people continue working on it. And you can have all kinds of branches going all over the place. This is just a simple design of it, and there's multiple types of branching strategies, and in the reference notes at the end, there's a link to a few of them. So I think the next thing is a demo. Yeah, so we're going to do two demos. We're going to create that web app and we're going to manage it with Git locally. We're not even going to be talking about Azure DevOps during that session, but the fundamentals behind it are the things that you're going to be using in number 2, which is we're going to create the web app again, except we're going to be using VS Code and Azure repos. I got 2 windows open here and a browser. All right, so in the top here, I'm going to make a new directory and I'm going to call it DevOps session 1. Change it, whoops, change into that. And I'm going to use, this is a built-in .NET application template generator. It's on, I don't know, it's on every computer I use, so it's either there by default or I accidentally install it. So I think it just, I'm pretty sure it's safe to say it's just there all the time. But you can generate a new web app really easily. You just type in .NET new web app -o is going to be the name of my web app. Web app is the template name, by the way. So my web app. And I'm going to use this flag just to avoid some errors when we're testing, is the no HTTPS error. So I'm going to run that. It takes a second. It's going to generate all the files I need to have a hello world .NET Core application. And in the bottom window, I'm going to change into that same directory. Now we see we have the My Web App folder in here. I'm going to change into it up there as well. And then to run my web app, I just type .NET run. This only takes a second. It's going to start up a web server on my local machine running on port 5000. There we go. So if I go over here, I should see it, and here's my hello world. Awesome. So what does this have to do with Git and repos and source control? Nothing yet. We are going to be using the git command to manage this. So if I were to change into this directory, my web app in the bottom, I'm going to leave the web server running on the top. So we have all these files in here that .NET command generated for us. I want to make this a Git repository. To do that, I need to initialize it, and it's super easy. It's just one command. We're just going to type git init, and it's now a Git repository. What does that mean? It means there is now a hidden directory on here called .git, and inside there's a whole bunch of stuff. This is basically all the files needed to keep track of all the changes that are happening within your repository. It's a log, it keeps track of pointers, all sorts of stuff. And if you're curious about what each and every one of those files means, there's a link to that in the reference so you can see. So that's all git init did. And now that I've done that, I can start using git commands like git status. If I were to change out of this directory and type git status, it tells me it's not a Git repository. All this is looking for is the presence of that .git directory, and then it knows it's a Git repository. So what does this mean? I type git status and I see untracked files. It's listing all the files that we just listed in that my web app directory. So we need to tell Git which files we want to track for version control purposes. I can say git add, which is considered a stage and forcing it to track. So it's saying, I want you to follow this file. I can say git add pages. I can do each and every one, or, well, actually, let me just do one. Type git status and see now pages is no longer there. Whoops, but it scrolls too fast. The green there, it's adding all the files inside of the pages directory, but I don't want to type that. So I'm just going to type git add dot, and it adds every single file. Now when I type git status, it's saying all of the, let's see if we can get it up to the top here. It's saying changes to be committed. So now the files are being tracked, but it wants to say, are you ready to commit these to the branch? Now, I'm currently working in the master branch, and I'll show you what that means in a second. But you need to make one commit after you initialize it. So I'm going to commit everything, and I'm just going to call this the initial commit. So there's all those files. Say git commit -m, and here -m is that important thing that lets you document where you are in your history. I'm going to say initial commit. So now I've done that. This create mode is updating those files in the .git directory, saying that it's tracking them. Now if I type git status, it says nothing to commit, working tree is clean. Awesome. So we didn't really do anything. We didn't change our code. The web app is still running in the background there. Nothing too crazy. But best practice is say, if you want to make a change, make a branch. So let's do that. Let's type in git branch -l to list, and we see all we have is a master branch. Let's make a new one, and we'll use that naming convention that we saw on the slide. We'll call it a feature, and we're going to change the banner. Now if I say git branch -l, we have two, but the star in the green here still says I'm on master, so let's change to it. I always want to say this command is export, but it's not. It is git checkout. So git checkout is what lets you switch to a new branch. Feature new banner 1. Now if I list my branches, I'm switched over to this. I'm just going to kind of get this other window in the background so you can see what this behaves like. Because we're going to make a change, and we're going to change the very first banner that shows up on that web page in the background. Actually, I'll put it right here. So let's make two really quick changes. I'm going to go into Pages. I'm going to edit this index file. And I'm going to find wherever this banner 1 is, right here. We'll call it new banner1.jpg. I'm going to save that. I'm going to go back into here. This is just that web app directory. I'm going to go into the images folder, and I have some files ready. We're going to change it to this. All right, I'm going to put that JPEG in there, and I'm going to get rid of the one that I don't want to use anymore. Great. So now if I go back to the web browser and I refresh this, my banner's changed, but notice I still haven't done anything in Git or the repository. Doesn't really matter. You can still make changes. The point is, once you make the change and you've tested it and you're comfortable with it, that's when you get to the point of staging and committing. I think I'm pretty comfortable with that. That's a pretty cool banner, I guess. So let's check out what's going on. We're working in that feature branch, so it's been monitoring that folder for us. If I type git status, I'm going to see I modified this file. That's true. I deleted that SVG file, the first image, and I added a new one. So it's separated like this because the top two are tracked files, and the last one is a file that it's never seen before, so it's not tracked. Git add, once again, it marks files for tracking and it stages them for committing. So I'm going to just say git add dot because I don't want to type in all three of those names. Do that. Git status again. We have these three files, changes to be committed. Sweet. I'll say git commit -m. New banner looking good. Git status again. No changes. That's it. So now if I wanted to continue to change this web application, every time I make a change, even that small, I can make a commit, and that way I can revert back to something else. So if I wanted to see all the changes I was making, I can type git log, and these commit codes are each step of the commit. So there's this first one was the initial commit, and there's my documentation, which is why it's so important. And this is me committing the new banner. If you got a lot, this list can get pretty tedious. So there's the smaller command, it's git reflog, and it'll just give you a one-liner for each commit. Okay, so let's go over that merging concept with our branch. Now we're happy with this. We had a task assigned to us, and we've updated it. And now we're ready to merge it in with the branch, so everyone else who starts working on this project gets the same changes. So we'll switch back to the master branch, git checkout master, and then we'll do a git branch just to make sure. Awesome. And now to merge it, we type git merge feature new banner 1. Awesome. So it's merged into master. And we will delete the branch because we're no longer needing it. Oh, new banner, sorry. Awesome. There we are, we're back with just one. Now let's do one more task with this, and we're going to recreate this much faster in VS Code. We're going to create another branch. We'll update the second image. A new banner 2. We'll change to it. Then we're going to make some changes again. We're going to go back into this file. I think this one was it. Yeah. We'll go back in here, pages, index, and we'll change it to new banner 2. Awesome. And let's check one more thing. And we'll go to, this is from another directory. Awesome. And we're going to go back into this folder and we're going to replace the image again. Just like we did last time, except this one's going to be new banner 2. And we're going to delete this. All right. So we got all these changes again, just like we did. We're going to add them again. We're going to commit them. New banner 2. Great. So, all right, let's go check out our web app. Let's move this up here. So there's our second banner. Looking pretty good. Looking pretty good. But let's say the person I presented this to was like, I don't really like that. Why did you choose that? You say, all right, it was a mistake. So let's check out our git ref log. And I want to revert back. So here's my commit comment. And here's my commit code. Copied the wrong thing. So let's say I want to revert this. I can just type git revert. Now watch if this works right. This folder up here where I have the 3 files, if I git revert and I put in the change code or the commit code, it's going to ask me, hey, you know, we're going to be making these, we're going to be reverting these changes. Add a comment. You can add a comment at the command line so this doesn't pop up, but so we'll say the comment. Cool. And now at the top, you see those files just change there. And that's the power of those branches and the commits and referencing and reverting back to things is you can switch back and forth between branches and it will update the file system accordingly so you can rapidly iterate through your code. So let's see, I think that covers everything for Git. So we're going to do this again, except we're going to do it in Azure DevOps and VS Code. So I'm going to stop this web server. I'm going to close that. Oh, this is another, just a screenshot on the right side of a more complex branching technique. The topics and the bug fixes is just another name for feature or bugs. And you can have multiple going on at the same time. All right, so let's do this in Azure DevOps. Just go to dev.azure.com and you can sign up for free. We're going to create a new project. This would be the screen you get right when you sign up, except you wouldn't have all these projects listed here. We'll click on New Project. Call it DevOps Session 1. Only takes a second and we'll be making a repository in just a minute. So on the left side here, These are all the topics we're going to be covering over the next few sessions. We're going to cover boards, which tracks your tasks and feature requests and all the bugs and stuff like that that you can tie to your code. Repos, which we're working on today. Pipelines is all the automation. Oops, sorry, let's get that back. And then we're going to go over test plans, which validate your code and make sure everything's okay when you deploy it, artifacts, and compliance. So we're working in repos. Let's make this stay so we can see it. I don't know where that is. Okay. Anyway, so files is going to be a file list of everything inside your repo. Commits is going to be a visual history of all the commits, just like we typed on the previous command, git reflog or git log. It's right there. Git pushes, that's when you're pushing your code into the remote repository. We didn't do a push because we were only working locally, but we will soon. Branches, you can see all the branches visually. If you have multiple going on, this helps a lot. Tags, if you need to tag, you can also tag your commits so that you can find them a little bit easier because, you know, documentation with a string of however many characters you can fit in there, maybe that's not good enough. You want to come up with a tagging process for that. And pull requests. Pull requests are going to be how you execute merges. All right, so let's start over. Let's go into files. I'm going to just create a new repo. We're going to call it DevOps session. Oh, I think I already used that, so call it DevOps underscore session 1. We're going to add a README file to the repository. This is a Markdown language, just like we use on the docs site. You can use your documentation as code in here as well. And we're going to add a git ignore file. Before I do that, I'm going to do one quick thing in the PowerShell windows we had back there. I'm going to type git status again. All right, it's cool. Let me clear the screen a bit. Git status. Nothing. I didn't change anything. This doesn't always work, so let's see what happens. I'm going to run that web app again. I do git status. Oh my goodness, all these things changed and I didn't change them. DLL files, PDB files. Being a wannabe programmer, I at least know that some of those files I don't need to check into my repository, but what do? Every time I go home for the day and come back, this thing is going to tell me I have these files and it's just going to be a huge hassle. What you can do is you can add a git ignore file. So not only did we have that hidden .git file or directory, we add a file called git ignore, and we just say which files we want to ignore. And that's it. You should do that ahead of time, because if you don't, these files, even though I added it, they're still being tracked. I need to manually stop tracking all those files. So it's a good idea to create that git ignore file right from the bat. And so on this left side here, that's why you see add a git ignore file. The template I'm going to use for this is Visual Studio. It's going to be a much more complex .git ignore file than me just adding 2 lines. So let's create that. And here's our visual representation of all the stuff that we were just doing. We got a master branch. There's no other branch, just like when we started. There's that README file in Markdown. And here's our git ignore file, which is way more way more things than what I was adding to that. So these are all the things that a build process usually needs to ignore. So it knows better than me. I'm going to trust that it's okay. Now we're going to use this in VS Code. I'm going to stop my web server. We don't need these anymore. And I'm going to open up VS Code somewhere. There it is. Okay, so since this is a remote repository, and like we said with distributed source control, there's a copy of the entire repo on every developer's machine, we're going to clone a copy of this repo to my machine. Click on clone in the top right. You can clone it in a whole bunch of different ways. You can do it on the command line through SSH, or there's a convenient little button here that lets you choose your development environment right here. I'm just going to clone this in VS Code. It's going to open up in VS Code. It's going to ask me where I want to save that copy. And we'll just say this directory. Cool, it's cloned. Let's open it. All right, so what do we got here? We got the git ignore file again, and we have our readme file. Sweet. All right, now let's do the web app again. Let's make a new one. Let's close that. So it was .NET new web app dash oh my web app dash no dash https. Nope, that wasn't it. What did I? .NET new. What did I not type here? Web app dash o. 1 second here.
You have 3 T's.
Oh, do I? Thank you. All right, so we're going to create this one more time. Let's hop over to here. Get ready to run it. .NET run. Oh, got to change to the directory. .NET run. Cool, it's waiting. Same deal, except we don't have our cool banner anymore. Awesome, so now what happened? This little icon over here that looks like the branching icon, it says 61. I have all my files here, all these files that were created before. I have the git ignore file already. I have 61 changes. So this window here is like a constantly updating window of the command git status. So I can cut a bunch of steps out of my process here if I wanted to. I can stage, commit, and synchronize all these changes to the remote repository all at once in one command, or I can do them one at a time, or maybe all of these files aren't quite ready, but I want to like set them aside and say only these ones are staged. So I'm just going to say these ones are staged and use this as a list to, I don't know, identify which ones I need to continue to work on. So you can stage individual files by just clicking the plus sign, and they'll go up here, and you can just keep on clicking on all of them. Or you can, like we did with that git add dot, you can say stage all, there it is, stage all changes. So they're all going to jump up to this stage changes section. And now I can do a commit. And it's going to ask me for my commit message up here. Same thing, initial commit. Awesome. And while we're doing this, let's go back here and let's synchronize. So it's asking me, it's going to push all my commits to master. Happens really fast. And if we refresh on the right side, there's all my files. So let's make that same change that we did with the banner. I'm going to go into www.root, pages first, index, and we'll change this to new banner. And let's find that file again. Banner 1. Over there. We're going to delete this file. All right, and that git reflog window is always checking. I deleted a file, modified this, and added it. Let's just skip it all. We're going to commit everything because we're happy with it. It stages it for us. It asks us what the commit message is. And let's sync it up. And I just broke my own rule. I just made a change on master. Shouldn't have done that. So let's make a new branch for that second banner. Down here in the bottom left, easy to miss, it says master. When you click on it, arguably not as intuitively as you would expect, you click on that and the command bar pops up at the top. We're going to create a new branch from, we're going to name it feature new banner 2. It's going to ask us where we want to, what our source is. We'll choose master. And now down again at the bottom left, we see we're on that feature branch. Let's go back to our file. We're going to change this to new banner 2. And let's move that file over. Cool. Awesome. Let's delete the other one. All right, so we should have, let's see. Did I do this in the wrong directory? I might have. I did. Underscore session. There we go. Go into here. Root images. And we'll paste this. Read it. All right. There we go. So I got these changes. Let's make sure it's working okay. First banner, all right. No, I messed up the second banner. What did I do? New banner 2. Save it. Let's see. Beautiful. All right, so there's my 3 changes. New banner 2 looks great. Commit it. Sync it. This is a good error. The branch feature new banner 2 has no upstream branch. Would you like to publish this branch? I'm not going to say okay. I'm just going to cancel it and talk about this for a second. When we go over to that repo, we see master. We don't see that branch because we're working locally. I'm going to publish that branch. Click there. And we should see that new branch in a second. And there it is. Okay, so now that we have the branch, my cat is probably going to try and walk on my keyboard, so apologies if it makes a noise. All right, so we're going to, what did we do? Last time on the command line, we merged that branch. So merging in Azure DevOps repos is considered pull requests, and pull requests enable that workflow process that we were talking about, where you are ready to merge your branch in the master and you're not on your own. You have people that want to do a code review and make sure that everything works okay. So let's make a pull request. Conveniently, we synced something to a branch, and right up here at the top, the repo noticed that, and it says, would you like to create a pull request? Sure, let's do that. That pull request is going to outline all the changes. I changed this line to that. I deleted this file. Here's what that new file looks like, and it's going to take the last commit that I made as the title for the pull request. It can be anything, though. I'm going to make this screen a bit bigger now that we're just going to stay here. So let's make this pull request. All right, so now here's where that review process comes in. You can set up people who are reviewers and approvers who are going to get notified when you make such a pull request, or you can just not merge your own changes and people can come in and look and see if there's any pull requests waiting and if they want to approve them or not. Sometimes you can set up policies that say at least 3 people need to be approved, need to approve of a pull request, or you can just say a specific person. Part of the homework is to look into the project settings and decide, not decide, but kind of just find out what you can do there. There's a lot of flexibility and it usually will fit any workflow. So here's my pull request. This is what the person who's approving it is going to see. They see those files that were changed again. They see updates, which it's not a lot, but this little line is my branch. And it's going to show all the commits. And the same commit code that we saw in the command line, that's right there. You can also revert them if you want to go back. All right, so I'm going to pretend I'm somebody else. I think that banner looks fantastic. I'm going to approve it. And if you needed 2 approvers, it would say 1 more approver needed. And I'm going to complete. Completing is a couple of things. It's going to run the git merge command that we ran. And it's also going to optionally run the git branch -D to delete the branch we were working on. So this checkbox here is the optional for deleting it. And we're going to use merge with no fast forward. The difference between that and squash commit is merge, no fast forward is going to keep, imagine I had a dozen commit changes here. If I squashed, it would remove all of those commit statements and just put that one pull request comment into the master branch. So we're going to keep all those comments because that's super valuable. And we're going to complete the merge and delete the banner branch. Cool, all done. Let's go back to our repo. No more feature branch there. That's pretty much it for managing your repositories through Azure DevOps. It's not necessarily faster, I guess. It can be, but it's more feature rich. It enables engineering teams to have that workflow designed, and a lot of people still use the git command because you totally can within the same repository within Visual Studio. So you can, if you're comfortable with that, or you want to have lots of street cred, all the cool kids use the command line, you can still do that here and forego using any of these here. So if this works out, like I said, first time we're doing it, so we're gonna do next week with a homework Q&A session. If you have questions now, of course, please feel free to ask your questions, but if you want to do the homework, we're going to talk about it in a little bit more depth next week. And the following session will be enabling continuous integration, which is building our Azure app service, getting it ready for deployment. And the homework is pretty straightforward, I think. Hopefully a little bit fun too. Create an Azure DevOps account. You just go to dev.azure.com. You're going to create a repo just like we did, clone it, and create a Hello World app. Create a new branch, change something, create a pull request, review those changes and merge. Just what I did. And some bonus tasks if you're interested. Set up someone else as your pull request approver. You just add their email address in. They'll get a note saying there's a pull request waiting, and they can go in and approve it for you. And also, if you're interested in what some more complex DevOps projects look like, there's a DevOps demo generator at aka.ms/DevOps demo generator, I think, that you can generate really cool looking projects way better than the Hello World C#.NET Core app. Those links, if you need them. I included one for Git versus TFVC, just if you want to see, there's many differences, but I just outlined the top two. A list of all Git command references, branching strategies, because there's much more complex ones like we saw in that image that was in my tab, and a link to the demo generator, and that link explaining what's inside that .git directory. So, does anyone have any questions? Cool. All right. Well, thanks, everyone.
Yeah, thank you so much, Mike. I will post this presentation shortly, right?
Great. Thanks so much.
Yeah, and I'll post this video as well. Thank you,
Awesome.
everyone, for joining. See you next Thursday for the homework session.
Yeah,
Thank you,
thanks.
everyone.
Bye.
Thank you very much.
Thanks. Bye-bye.